The Earth is spinning at 1,000 miles per hour. So why don't we feel this tremendous speed? You would think we'd be constantly dizzy, our hair whipping in the wind. Yet, here we are, enjoying a calm cup of coffee, completely oblivious to the cosmic carousel beneath our feet. The answer, my friends, lies in the fascinating interplay of gravity, inertia, and something called a frame of reference. Don't worry, we'll unravel these concepts together. By the end, you'll have a newfound appreciation for the subtle forces that shape our everyday experience. Let's embark on a journey to understand why we don't feel the Earth spinning. Our planet is in constant motion. It rotates on its axis, an imaginary line passing through the north and south poles. This rotation is what gives us day and night. The Earth completes one full rotation in about 24 hours. Now let's talk speed. The Earth's circumference is roughly 25,000 miles. To complete a rotation in 24 hours, points on the equator have to move at a speed of roughly 1,000 miles per hour. This speed decreases as you move towards the poles. You might be thinking, whoa, that's fast, so why aren't we flung off into space? Gravity is the cosmic glue that holds us to this spinning sphere. It's the force of attraction between any two objects with mass. The Earth, with its massive size, exerts a strong gravitational pull on us. This pull is always directed towards the center of the Earth, no matter where we are on the planet. It's what keeps our feet planted firmly on the ground, even as the Earth spins beneath us. But gravity isn't the whole story. To understand why we don't feel the Earth spin, we need to talk about inertia. Inertia is the tendency of an object to resist changes in its motion. This fundamental principle is a cornerstone of classical physics and helps us understand the behavior of objects in our everyday lives. Whether it's a spinning wheel, a moving train, or a satellite orbiting Earth, inertia plays a crucial role in how these objects maintain their state of motion. An object at rest wants to stay at rest, and this is something we can observe all around us. Take, for example, a rock lying still in a field or a parked car. These objects will remain stationary unless acted upon by an external force. This resistance to change is what we call inertia. Conversely, an object in motion wants to stay in motion at the same speed and in the same direction. Imagine a car driving smoothly on a highway, a plane flying steadily through the sky, or a boat cruising on calm waters. These objects will continue their motion unless something interferes, like friction, air resistance, or another force. This concept was first described by Sir Isaac Newton in his Laws of Motion. Newton's first law, often called the law of inertia, states that an object will remain at rest or in uniform motion unless acted upon by an external force. This groundbreaking idea laid the foundation for much of modern physics and has been instrumental in our understanding of the natural world. We don't feel the Earth spinning because we are moving along with it. The Earth rotates at a staggering speed of about 1,000 miles per hour at the equator, yet we are blissfully unaware of this motion. This is because we, along with everything else on the planet, are moving in unison with the Earth's rotation. We, along with the atmosphere, oceans, and everything else on Earth, are all rotating together at the same speed. This synchronized movement means that we don't feel the Earth's rotation in our daily lives. It's a bit like being on a smoothly moving train. As long as the motion is constant, we don't notice it. It's like riding in a car. You don't feel the speed as long as the car is moving at a constant velocity. When you're inside a car traveling smoothly on a highway, you don't feel the motion because you and the car are moving together. The same principle applies to the Earth's rotation. Our bodies are going with the flow of Earth's rotation. Just as synchronized swimmers move in perfect harmony, we move in sync with the Earth. This seamless motion is a testament to the power of inertia and the interconnectedness of all things on our planet. But there's one more piece to this puzzle: frames of reference. Understanding frames of reference is crucial for comprehending motion. A frame of reference is essentially a point of view from which we observe and measure motion. For example, when you're on a moving train, your frame of reference is different from someone standing on the platform. This concept helps us make sense of the relative motion of objects and is fundamental to the study of physics. Imagine being on a merry-go-round or a Ferris wheel. From your perspective, you might feel like you're stationary while the world spins around you. However, to an observer on the ground, you're the one in motion. This difference in perspective is what frames of reference are all about. Similarly, when you're running on a treadmill or cycling on a stationary bike, your frame of reference is different from someone watching you. To you it feels like you're moving, but to an observer, you're staying in one place while the treadmill or bike moves beneath you. Understanding these concepts helps us grasp the complexities of motion and the forces that govern it. By studying inertia and frames of reference, we gain a deeper appreciation for the natural laws that shape our world. These principles are not just abstract theories, they have practical applications in everything from engineering to space travel. For instance, when launching a rocket into space, scientists must account for the Earth's rotation and the inertia of the rocket. Astronauts in space experience different frames of reference as they orbit the Earth, and understanding these principles is crucial for their safety and mission success. So the next time you go about your daily activities, take a moment to appreciate the invisible forces at play. Whether you're walking, driving, or simply sitting still, you're part of a grand cosmic dance, moving in harmony with the Earth and the universe. Embrace the flow and marvel at the wonders of motion and inertia. A frame of reference is our viewpoint. It's how we perceive motion. Imagine you're on a train, looking out the window at another train moving alongside you. For a moment, it's hard to tell which train is moving and which is standing still. That's because your frame of reference is relative to the train you're on. On Earth, our frame of reference is also relative. We don't feel the Earth spinning because we're observing it from the same rotating frame of reference. From our perspective, we are stationary, and the world is spinning around us. To better grasp this, let's consider some familiar examples of rotation. Section 6. Round and round we go, the rotating platform analogy. Imagine standing on a slowly rotating platform like a carousel. The platform moves at a gentle pace and you stand there feeling quite stable. As long as the platform rotates smoothly, you wouldn't feel much different from standing on solid ground. Your feet are firmly planted and there's no sense of imbalance. You might notice the scenery changing, indicating movement, but you wouldn't feel a strong force pushing you sideways. The gentle rotation is almost imperceptible. Now imagine that platform is enclosed, and you can't see the outside. The walls around you block any visual cues of movement. You might not even realize you're moving. Without the visual reference, the sensation of rotation is almost entirely absent. This is similar to our situation on Earth. We are on a massive rotating platform, but we don't feel it. The Earth is our rotating platform, and the atmosphere is the enclosure that prevents us from seeing the rotation directly. The atmosphere acts like the walls of the enclosed carousel. Let's try another analogy to solidify this concept. Imagine you're in a car moving at a constant speed on a smooth highway. Inside the car you feel stable and don't sense the motion. It's only when you look out the window and see the scenery whizzing by that you realize you're moving. Similarly, on Earth, we don't feel the rotation because everything around us moves with us. The atmosphere, the ground, and everything on it are all rotating together at the same speed. This synchronized movement creates a sense of stability, just like the car on the highway or the enclosed carousel. The only time we might sense the Earth's rotation is through indirect evidence, like the way the stars move across the sky or the way weather patterns shift. But in our day-to-day lives, the rotation is imperceptible. This analogy helps us understand why we don't feel the Earth spinning beneath our feet. It's a fascinating concept that highlights the incredible balance and harmony of our planet's movements. So next time you stand on solid ground, remember that you're actually on a giant, smoothly rotating platform, moving through space with a grace that we rarely notice. Section 7. Smooth sailing on Spaceship Earth. Think of the Earth as a giant spaceship traveling through space. This spaceship, our home, is on an incredible journey, orbiting the Sun at an average speed of about 67,000 miles per hour. Yet, we hardly notice this rapid motion. We are all passengers on this spaceship, strapped in by gravity. Just like passengers on an airplane, we are securely held in place, allowing us to go about our daily lives without feeling the immense speed at which we are traveling. The spaceship is constantly rotating, completing one full spin every 24 hours. This rotation is what gives us day and night. But because we are moving along with it, at the same speed and in the same direction, we don't feel the movement. It's a seamless experience. It's like flying in an airplane. When the plane reaches its cruising altitude and speed, the sensation of movement diminishes. You don't feel like you're hurtling through the air at hundreds of miles per hour. Once the plane reaches cruising altitude and speed, you don't feel like you're hurtling through the air at hundreds of miles per hour. The environment inside the cabin becomes stable and comfortable. You can walk up and down the aisle, sip your drink, and even forget you're in the air. The stability of the environment allows you to relax and enjoy the journey. Our senses are designed to detect changes in motion, not constant motion itself. This is why we can feel the acceleration during takeoff and landing, but not the steady cruise. This brings us to a fascinating point. The Earth, much like an airplane, provides a stable environment for us. Despite its constant motion through space, we experience a sense of stability and normalcy. This is a testament to the incredible design of our planet and the forces that govern it. As we continue our journey through the cosmos, it's important to remember that we are all in this together. Our spaceship Earth is a shared vessel, and we must take care of it and each other to ensure smooth sailing for generations to come. By working together and understanding our place in the universe, we can create a better future. Just as passengers on an airplane must cooperate and follow certain rules for a safe flight, we too must collaborate and act responsibly to maintain the health and safety of our planet. So the next time you look up at the sky or feel the ground beneath your feet, remember that you are part of an extraordinary journey on Spaceship Earth. Embrace the adventure, cherish the stability, and contribute to the well-being of our shared home. Together we can ensure that our voyage through the cosmos remains a smooth and wondrous experience for all. Smooth sailing on Spaceship Earth indeed. Section 8. Beyond our senses, the unseen world. There's a whole world of phenomena happening around us that we are completely unaware of because our senses are not equipped to perceive them. We don't feel the Earth spinning, just like we don't see radio waves or hear dog whistles. Our understanding of the universe goes beyond what we can directly experience. We rely on scientific instruments and theories to extend our senses and reveal the hidden workings of the cosmos. So the next time you gaze up at the night sky, remember. Section 9. Keep looking up. The universe is full of wonders, many of which are beyond our immediate perception. The fact that we don't feel the Earth spinning is a testament to the elegant laws of physics that govern our existence. As you continue your exploration of the cosmos, keep asking questions, keep seeking answers, and never stop marveling at the unseen forces that shape our world. Now I leave you with this question. What other scientific phenomena do we not notice in everyday life?